Hello everyone, and welcome to my Capstone presentation for the Master of Science in Business Analytics. My name is Alex Rayo, and my research project is titled Data Analytics in Fantasy Football, Identifying Production at Running Back. The motivation of my analysis can be defined through the following research question. Which key features influence running back production in fantasy football? It is the consensus opinion of the fantasy football community that elite running back production is one of the main requirements for a successful fantasy team. In a standard fantasy league, managers must select at least two backs from their team to insert into their weekly lineup, with potential for a third depending on the league format, via flex. On any given play in an NFL game, only one running back is typically on the field at a time, and most teams only trust the position to one or two players. We must consider the violent nature of football and the injuries associated with it, especially at running back. Add in bye weeks where certain teams don't play, the potential exposure to illnesses such as COVID-19, and we are left with an underwhelming amount of relevant players that must comprise the depth of our roster in anticipation of these realities. This leaves fantasy football managers with some difficult choices to make during the draft process for team selection. Available resources for managers to use in the draft include expert rankings and projections and metrics from previous seasons. In an effort to formulate my own opinions of these players, I have chosen to focus on the latter from my research. The data required to conduct this analysis is exported from a source known as fantasydata.com. This website is a subscription-based platform that provides users availability to counting statistics and calculated metrics from current and previous seasons, as well as the ability to easily export them into Microsoft Excel. The first spreadsheet I selected for my analysis is based on the 2021 NFL season and is titled Fantasy Football Stats and Season Leaders. It includes the final standings relating to fantasy measures such as fantasy points scored and rank. The second spreadsheet is titled Advanced Efficiency Metrics and is also based on the 2021 NFL season. It includes non-counting scoring metrics such as juke rate, yards created, and evaded tackles. I used Power Query and Excel to easily join the two sheets. The final Excel data was then imported into SAS and used for analysis. The target variable used for this study is titled Top 15. It is a binary variable that indicates whether or not the observation, or player, finished in the top 15 of running back scoring for the 2021 season. The two levels are Y for yes, the player finished in the top 15, or N for no, which means they failed to finish within the top 15. Of the 27 variables, 5 were rejected as they directly relate to fantasy points and would be redundant in terms of analysis. These metrics would be more relevant to a study regarding consistency. The data is of extremely high quality and includes no missing values for all 54 observations. I have also included fantasy rank as an ID variable for the analysis. Finally, I'll discuss the analysis that I performed within SAS Enterprise Miner for this research study. After importing the data in a separate diagram and creating the data source, I ran a Stat Explorer node to have a closer look at the data. I then decided to partition my data using 60% training and 40% validation. I used this specific allocation based on the extreme quality of the data and lack of missing values. I then used the transform variables node to handle outliers and smooth some of the skewness associated with specific variables. After performing different techniques and variations of those techniques, I decided on the following models to use for my analysis: stepwise regression, DM neural, decision tree, HB forest, and gradient boosting. Lastly, I used the model comparison node to assess the models in terms of their respective misclassification rates and average square errors. Thank you for listening, and have a great day.